Good morning, afternoon, or evening. How you doing today? Welcome back to Mr. Morrell's Algebra 2 class. We're still having some issues with the rational word problems, so I put up some more examples here. Hopefully they're a little bit challenging for you, and this way we could really understand how to work with them. What I'm going to do is I'm going to split it into two screens, and hopefully we can go from there. Okay, so let's see what we got here. Okay, the first one says that an airplane whose speed in still air, actually this is going to be very hard for you to see. Give me 1 second. Okay, I think this is going to be a lot better. All right, so what's happening here? An airplane whose speed in still air is 370 kilometers per hour can travel 1,000 kilometers with the wind in the same time. It travels 850 kilometers against the wind. Remember that when it's with the wind, you're adding to the rate, right? Okay? With the wind, you're adding the wind. Against the wind, you're subtracting the wind. Think of when you're riding a bike, downhill, and you feel the wind hitting your face. It's actually slowing you down a little bit. Think about when there's a breeze and it catches behind you. That helps you go forward. It helps propel you. So, as always, let's make our table. Believe it or not, this table is what saves the day for me. Rate times time equals distance. And we've got a plane that's going with the wind. And we have a plane that's going against the wind. So that's how we start out. We start out by labeling. And it says that the airplane in still air is, the speed is, an airplane whose speed in still air is 370 kilometers per hour, can travel 1,000 kilometers. So it's going to travel 1,000 kilometers, okay, in the same time that it travels 850 kilometers against the wind. Okay. Now they tell us that the speed is 370 kilometers in still air. But we're talking about with the wind and against the wind. So the rate of the plane with the wind would be 370 miles per hour plus the wind speed. And the speed of the plane against the wind would be 370 kilometers per hour minus the wind. Now, the time. This is the part that gets us always. And trust me, it used to get me a lot as well, until I realized you can't have two different variables, or you can't have the same variable represent two different things. So a lot of people will say, oh, it's the same time. Oh, what do I do? Put a t in a t. That's going to be a very nasty system of equation, and you're not going to get it very well. So instead, let's try to remember that distance equals rate times time. And in this particular case, time equals distance over rate. Again, the problem that most of my students have with this is they say, how do you know when to do it? The answer is simple. When you have to put two different unknowns in these types of problems, you can probably revert to switching around the distance formula. So since time equals distance divided by rate, time will equal 1,000 divided by the rate with the wind, and the against time will be 850 divided by the against the wind speed. Does that make sense, everybody, so far in the table setup? The equation, I think, at this point is pretty easy. Is this good? Now, we have large numbers, and like I've said before, engineers use calculators, but they can't have a calculator do the setup for them. So as long as you guys understand the setup, and then you set up the equation the way I'm going to set it up, you may use calculators for the calculations that are going to take you time. So in this particular case, remember, please, sorry to go back up again, up and back, up and back. Please remember that in the same time. Okay? So being that he was going with the wind, the plane is going to travel a lot further, okay, in the same amount of time. So time is equal here. So 1,000 over 370 plus the wind speed, that's the time that it took the plane going with the wind to travel 1,000 kilometers. That equals the same time that it took the plane to go against the wind, 850 miles. Go ahead and cross multiply, and you're going to get 370,000 minus 1,000 W equals, I'm going to go to my little calculator now, save time, 314,500 plus 850 W. Does everyone see what I did? All I did here is basically I cross-multiplied. I basically multiplied by the LCD to both sides. When I multiplied it to this bad boy, that canceled. Hence, I had to do 1,000 times 370 minus W. When I multiplied it to this side, the 370 minus W cancels. So I had to multiply 850 to the 370 plus W. Are there any questions so far? Please. Anything at all? Okay. So now let's go ahead and subtract 314,500 to both sides. And at the same time, to save some time and space, let's multiply 1,000 W to both sides. And that is going to give me 370,000 minus 314,500. We got 55,500 is going to equal 1850 W. Divide both sides by 1850. This is the usefulness of the calculator. Divided by 1850, and that will be 30, not miles per hour, but kilometers per hour. Does everyone see what I did there? Any questions, please? Yes, sir, thank you. Okay, let's look at the question. The question was, do you then plug it in? Find the speed of the wind. In this particular case, the speed of the wind is what we found. Now, if they ask you, find the speed of the plane while it was traveling with the wind, you would add 30 to 370, and that would be 400 with the wind. If they asked, find the speed of the plane against the wind, then you would subtract the 30, and then it would be 340 kilometers per hour. So yeah, it depends on what they ask. Thank you very much, sir. Okay, let's go to number 2. I know that number 2 really stressed you guys out a lot. And no worries. That's what I'm here for, okay? Hopefully we're going to take care of all that stress today. We're going to make sure that it goes bye-bye. All right. So a train required 2 hours longer to travel 500 kilometers than a plane required to travel 1,200 kilometers. So right now, we've got a plane and a train. And the train required 2 hours longer to travel 500 miles or kilometers than the plane to travel 1,200 kilometers. Okay, but how do we figure that out? The train required 2 hours longer. Do we know how long? Who do we know nothing about? How about that? Yeah, I know we have to set it up, but as far as the time goes, what do we know nothing about? The plane. We know that the train required 2 hours longer than the plane. So the plane would be called X. Okay, well, let's do my rate times time equals distance. So the time of the plane was X. Now, if the train took 2 hours longer, what? Thank you very much. It'd be the plane's time plus 2 more hours. Does everyone see that? Now, this is the part that kills it. Find the speed of the train if the plane travels 4 times as fast as the train. Wait a second. We got a problem here. We don't know anything about the train speed, but we know this. Whoa, what's the problem here? Yeah, we have two different x's. We have x's for the rate and we have x's for the time. We can't do that, my friends. So let's remember the basics. Distance equals rate times time. So that means that rate equals distance divided by time. So the rate of the plane was the distance divided by time. The rate of the train, I'm sorry, time is x. And the distance of the rate of the train is the distance 500 divided by its time. Now, what does it say about the rate? Find the speed of the train if the plane travels 4 times as fast as the train. So doesn't the plane, which is 1200 over x, doesn't that travel, that equals 4 times the speed of the train, my friends? Does that make sense? Okay, now, I'm going to continue with this. I don't want to try to kill you or anything, but you could have done this too. You could have said this was x, this was 4x, and then the time would have been 1200 over 4x, and then the time for the train would have been 500 over x, and then you would have you have to remember that the train took 2 hours longer than the plane, right? So then the train speed equals 2 hours more than the plane speed. You feel me? So you didn't have to go the blue route. You could have gone the red route. But I chose the blue route. I think for me, it's an easier setup in my opinion. So now let's go ahead and cross multiply. So I've got 1200x plus 2400 equals 2000x. So 2400 equals 800x divided by 800. X equals 3 hours. They were asking for, find the speed of the train. So the speed of the train, okay? Remember that, guys, the speed of the train. So if x is 3, what is the speed of the train? 500 divided by 5, which is 100 kilometers per hour. Did you see that there? You see how that all worked out? The promise. Do you see the confusion? Yes, sir. You could have just straight up found x and then multiplied by 4, sure. But I just put it all together in one, okay? All right, I don't have much time left. Would it be okay if I just set these last two up, please? And thank you. Okay, we got some work problems now. I know you love the work problems. Okay, let's see what we got. LaToya can paint 10 by 14, 10 foot by 14 foot rooms by herself in 14 hours. So this is very similar, okay, to the distance because rate times time equals work done. All right. Lisa can paint 5 10-foot by 10-foot rooms by herself in 10 hours. Working together, how long would it take to paint 5 10-foot by 14 foot? This should be 14 feet rooms. Okay. Well, LaToya, her rate is 14 hours, so 1/14 of the job is done every hour. And that's LaToya. Lisa, L-I, can paint the same amount of rooms in 10 hours. So her rate is 1/10 of the job per hour. Okay? Working together, how long would it take? How long would it take when they're working together? Well, the work done by LaToya at her rate is x over 14. The work done by Lisa at her rate is x over 10. And LaToya's rate plus Lisa's rate equals 1 complete job. Multiply everything by 140 and solve from there, my friends. Sorry, did that make sense? Sorry, I know I'm going fast now. Ran out of time. I got too involved in the discussion. Sorry about that. I will finish this one right now. Okay. Alessandra and Frank can assemble a King Kong set working together in 6 hours. So this time it's a little bit different. This time they give you the time. Rate times time equals work done. The bell rang. I will finish it now. I don't want you to be late to your class. I'm going to pause it for a second. I'll let you get out of here. Go. Have a great day. God bless you all. Try to be quiet so I can finish this up for you guys. Okay? So rate times time equals work done. And we have Alexandra and we have Frank. Okay, so Alex and Frank can assemble a King Kong swing set working together in 6 hours. So their time working together is 6 hours. One day Frank called in sick, and Alexandra was able to assemble the King Kong swing set in 10 hours. So her rate was 1/10 of the job every hour. How long would it take Frank to assemble the King Kong swing set if he worked by himself? Well, we don't know his rate, so the work done is 6/10 over 6 over x. So 6/10 of the job plus 6x of the job equals 1 complete job. Multiply by 10x to both sides, and bingo, you're done. Thank you very much and have a great day. I hope you learned a lot. Study for that quiz.